In this video, we look at a couple more examples of evaluating functions evaluating integrals, using the fundamental theorem of calculus. All of our normal rules for antiderivatives still apply here. We're able to distribute it across addition and subtraction, and we can pull constants out. So we can first do the antiderivative of x cubed plus 5x to the second. So for x cubed, we'd add 1 to it, divide by it. That'd be 1/4 x to the fourth. For 5x squared, we'd add 1 to the x squared exponent, making it 3, and then divide by it. That would give us plus 5/3 x to the third. And then that's going to be evaluated between 1 and 4. So we're going to plug 4 in everywhere we see the x, get an answer. Plug 1 in everywhere we see an x, get an answer, and then evaluate it. Okay, so plugging in 4, we would have 1/4, 4 to the fourth, plus 5/3 times 4 cubed, and then minus, plug 1 in everywhere we see an x. 1/4 times 1 to the fourth, plus 5/3 times 1 to the third. And at this point, I've just gone straight to a calculator and computed this and got 168 3/4, 168.75. And I'm perfectly fine with the decimal answer, although be careful with some of the homework problems. They may require you to express things as a fraction. And let's consider another example. Integral from 0 to pi of sine x dx. This is one we would be hopeless for with our sums. We would be in really rough shape trying to do the integral from 0 to anything of sine x. But using antiderivatives, we can do this pretty quickly. What function would we differentiate to get sine? Well, sine, when it's integrated, is negative. Right? It would be negative cosine x evaluated at pi and at 0. So then we just plug those in. Negative cosine of pi minus negative cosine of 0. Remember, cosine of pi is -1. That's the negative of -1, which would be 1. And cosine of 0 is 1, so it's minus a -1, which would be +1. So it turns out this integral of this sine function from 0 to pi is actually the whole number 2. And that's just a really wild idea to me, that this non-algebraic function here, sine x, actually has an integral, from what we'd think of as kind of normal values to pick, like 0 to pi, and it actually has a nice integer area. And that's, again, just to me, really kind of strange that happens. So really kind of cool as well. So the integral of sine from 0 to pi is 2.